Okay, this video accompanies the 3-2 worksheet, Properties of Parallel Lines, which is part of our Chapter 2 review. So in this, we want to identify the postulates and the theorems about the parallel lines. And so kind of as a reference, I'm going to label these theorems and postulates so we can refer to them as we go through the exercises. So A, we're going to have this: if two parallel lines are cut by a transversal, then corresponding angles are congruent. So we'll call that A. B, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. C, if two parallel lines are cut by a transversal, then same side interior angles are supplementary, which means they add to 180 degrees. And then one that we haven't really had in our text is if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other one also. So if you think about it, it kind of makes sense. If this transversal makes a right angle with one line that's parallel to another line, then corresponding angles are going to let us throw that right angle up to the other line, which also shows that the transversal is perpendicular to that one also. So we'll call that D. So in the exercises below, we want to identify the postulate or theorem that's at work that lets us say that those lines are, or those angles are congruent to each other. So 3 congruent to 7. If we look at 3 and 7, now notice that I and K lines are marked as being parallel to each other, and 3 and 7 then are corresponding angles. And the corresponding angles theorem in terms of these ABC letters are, let's see which one. A is the corresponding angles one. So A is the postulate that goes with number 1. Let's look at number 2, A perpendicular to K. If A is perpendicular to K, they're showing us in the diagram that A is perpendicular to I, or it's either I or J, which is parallel to K. So using D, if a transversal is perpendicular to one of two parallel lines, it's perpendicular to the other one also, is the one that works to let us say that A must be perpendicular to K. So D goes with that one. Number 3, the measure of 6 and 7 is 180. 6 and 7 are a pair of same side interior angles. So same side interior angles theorem is C. Angle 6 congruent to angle 8. If we look at 6 and 8, we can see that they're on alternate sides of the transversal inside the two parallel lines. This makes them alternate interior angles. The alternate interior angles theorem is B. So 4 goes with B. 4 congruent to 6, those are vertical angles. They're always going to be congruent because they're vertical angles. It has nothing to do with lines being parallel. Angle 1 congruent to angle 2. If angle 1, well, no, okay, we have a linear pair here, and one angle is 90 degrees, so the linear pair means that 180 take away 90 leaves angle 1 to have a measure of 90 degrees, which makes it a right angle. And then angle 1 and angle 2 are in corresponding positions, so that lets us know that angle 2 is also 90 degrees. So the end result is that corresponding angles are congruent, but to actually get they're corresponding angles, but we could say that they're 90 degrees also using the linear pair idea. But corresponding angles is probably the best choice. That's going to be A. Angle 5 congruent to 7, or the measure of 5 equal to 7. 5 is equal to 7 because 5 and 7 are alternate interior angles, which goes with B. And angle 5 supplementary to 8. 5 and 8 are same side interior angles, which makes them supplementary, and that goes with C. Let's move on. For number 9, we want to name the 7 angles that are congruent to angle 1. So a lot of times, as long as you're using a pencil, the best way to kind of do a diagram like this is to basically mark all the corresponding and alternate interior angles that are congruent. So I've got angle 1, Angle 3 is a corresponding angle. Angle 6 is congruent because it's a vertical angle. Angle 8 is congruent to 3 because it's a vertical angle. Using the parallel lines going the other way, angle 1 and angle 9 are congruent because those are corresponding positions. 9 and 14 are congruent because they're vertical, or 6 and 14 are corresponding. And 3 and 11 are in corresponding positions, so they have to be congruent. And then 16 is congruent because it's a vertical angle. Or we could also say that 8 and 16 are corresponding. So the angles that I have marked here are all the angles that are congruent to angle 1. So they want us to name those. So we'll do it down here. We've got angle 1 as our reference angle, but we don't have to really do number order, but try to do number order. We've got angle 3. We've got angle 6 and angle 8. We've got 9 and 11. And we have angle 14 and 16. See if there's 7. 1, 2, 3, 4, 5, 6, 7, and then angle 1 makes 8. Okay, so those are the angles that have to be congruent to angle 1. Now, the angles that have to be supplementary to angle 6, if we look at the diagram the way we have it marked up, all these other adjacent angles make linear pairs. So all the angles that we don't have marked from number 9 are going to be the angles that are supplementary to angle 6, because angle 6 is congruent to angle 1. If they're supplementary to angle 1, they're also going to be supplementary to angle 6. So these other angles are the angles that are going to be supplementary angles. So let me list them down here. So we've got angle 2 and angle 4. We've got angle 5 and angle 7. We've got angle 10 and 12. And angle 13 and angle 15. There should be 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we got all 8. Let's look at number 11. So if the measure of angle 5 is 60, so let's throw a 60 in there. What are the measures of the other numbered angles? Well, all the angles that are congruent to angle 5 are going to be 60s. And the angles that are congruent to angle 5 are the ones that we just marked in 10. So these same angles, angle 2, angle 4, angle 5, angle 7, 10, 12, 13, and 15, are all going to have measures equal to 60 degrees. And the other angles are supplementary, which means angle 1, angle 9, 3 and 11, and 8 and 16, and 6 and 14 are all going to be supplementary to the 160. They're all going to be 120 degrees. So I'm going to, this would be part A, number 11. 11B will right up here at the top. These are all the angles that are going to be 120 degrees. Okay, let's look at the next page. So let's look at our example. If the measure of angle 1 is 120, find the measure of these other angles. So let's see. They're showing us that we have a system of 2 sets of parallel lines. And so if we look at angle 1, we can see that angle 1 and angle 5 are corresponding. So if 1 is 120, angle 5 is going to be 120. By vertical angles, angle 6 is going to have a measure of 120. By corresponding, angle 6 and angle 4 are congruent, so angle 4 is going to have a measure of 120. And then by corresponding positions, angle 4 and angle 2 are congruent, so angle 2 is going to have a measure of 120. And then angle 2 and angle 3 are a linear pair, which means they have to add to 180, and 180 take away 120 leaves 60, so angle 3 is going to be 60. So we kind of solve the diagram, and let's use that to answer the question. Measure of angle 2 is 120. Measure of angle 3 is 60. And measure of angle 4 is 120. Okay. Okay, so we'll pretty much have to do the same thing, I think, for these exercises. It's better to kind of take a little bit of time and completely solve the diagram and then answer the questions rather than to try to go, step by step and zigzag back and forth in terms of like the amount of time that it takes. So for number 12, it's telling us that the measure of angle 2 is 80. So I'm going to mark angle 2 is 80 degrees. Let me switch colors up here. So angle 2 is going to be 80. And it wants to know the measure of angle 6. So angle 6 is corresponding. That's going to be 80. And let's look at angle 7. Angle 7 is a linear pair, which is supplementary to 80. 180 take away 80 leaves 100. So angle 7 is going to be 100 degrees. Let me erase those and we'll go to the next part. If the measure of angle 9 is 105, let's find angle 9, that's 105. What's the measure of angle 10? Angle 10 is a linear pair with 9, so 180 take away 105 gives us 75 degrees for 10. And the measure of angle 16 then, let's see, so if angle 10 is 105 and these lines are parallel, then angle 10 and angle 16 are alternate interior angles. Angle 16 also has to have a measure of 105. So that's how we get that one. Okay, let's look at the next one. Switch colors up. Measure of angle 8 is 85. So throw 85 in there. What's the measure of angle 16? Angle 16 is corresponding. So it's going to be 85. Angle 10. See what we can do. Angle 10 is an alternate interior angle with angle 16. So that means angle 10 is also going to be 85 degrees. Get rid of those. Go to the next one. If the measure of angle 15 is 95, let's put 95 in for 15. And they're talking about angle 8. So let's see. So if we go with alternate exterior angles, if 15 is 95, angle 5 is going to be 95 because those are alternate exterior angles. And then 8 and 5 are supplementary to each other. So 180 take away 95. I'm going to have to borrow here. So 9 or 10 take away 5 is 5. And we end up with 85. So 85 is going to be the measure of, let's see where we at. Measure 15 is 95. So the measure of angle 8 is going to be supplementary to 95. So that's going to be 85 degrees. And the measure of angle 1 then is going to be 95 because that's a corresponding position angle with angle 5. It's going to be 95 degrees. Let me erase these and go to the next one. Let's use pink. Okay, if the measure of angle 3 is equal to the measure of angle 4 plus 30. So this angle 4 is 4 plus 30. But together these make a linear pair. So let's see what we can get out of that. So the measure of angle 3 is equal to the, so we can see that 3 and 4 together. So measure of angle 3 plus measure of angle 4 has to be 180. Because these are a linear pair. But it's also telling us that angle 4 is the same, or angle 3 is the same thing as angle 4 plus 30. So measure angle 4 plus 30 gets substituted in for measure of angle 3. We still got our measure of angle 4 added with that. That makes 180. So now we have two measures of angle 4 plus 30 equals 180. take away 30 from both sides, 2 measures of angle 4 equals 150. Divide by 2, the measure of angle 4 is 75. So 4 is a 75. Let's see, they want us to find the measure of angle 5. We could do alternate exterior angles. If 4 is 75, 6 is going to be 75. 5 is a linear pair with that. 180 take away 75 gives 105. So the measure of angle 5 is 105 degrees. Okay, let's look at the next set here. If 16 is 13 minus 20, so if 16 is 13 minus 20, okay, again, these two are a linear pair. They want us to find the measure of angle 11.
It's on my.
Okay, let's look at this next one. So measure of 16 is 13 minus 20. The 16 and 13 together make 180. So this is kind of the same type problem. So the measure of angle 13 plus the measure of angle 16 has to be 180 since they're a linear pair. But 16 is the same thing as 13 minus 20. So measure of angle 13 minus 20 gets substituted in for measure of 16. We still got measure of 13. So all those together add up and make 180. So we have 2 measures of angle 13 plus 20, or take away 20, equals 180. We're going to add 20 to both sides. 2 measures of angle 13 equals 200. Divide by 2, measure of angle 13 equals 100. So angle 13 is 100. Now let's see what they're asking us. They want us to find the measure of angle 11. Well, 11 and 13 are alternate interior angles. So angle 13 must also have a measure of 100. And we're not going to worry about these proofs. So we'll skip those. Let's click on. So get part 2. One second here, let me make sure. Yeah, we're going to do part 2 here. So state and apply the postulates and theorems about parallel lines. So if parallel lines are cut by transversal, then we got corresponding angles congruent. We have alternate interior angles congruent, and the same side interior angles are supplementary. Okay, so we won't worry so much about the example. Basically, these two are going to add up to 180. So 8x's is 180. We can figure out what x is that way. And these two together are supplementary. So we could also say that 5x plus 105 equals 180 and figure out what x is that way also. Down here we have an exterior angle. These two angles together inside, so the supplement to y, which is the same thing as x, using the parallel lines with the transversal, we can actually jump the x up here. So basically we got 2 x's makes 120 using the exterior angle theorem. And if this is a 60 then, and this is a 60, that means this one has to be a 120. So that's a way we can figure out what y is, using the alternate interior angles and then the linear pair. So see what we got going on down here with these at the bottom. They want us to find the values of x and y. So we're on part 2 now. So let's see what we got. These are parallel lines. Here's the transversal at the bottom. These two have to be supplementary to each other. Or also we know that this has to be a 90. It's either corresponding or parallel lines is perpendicular one is perpendicular to the other. But 5x is going to be 90. Which means x is going to be 18. Now we want to find out what y is. Together these are same side interior angles. These have to add up to 180. So we have 6y plus 3y equals 180, which gives us 9y's is 180, which gives us y is equal to 20. So y is equal to 20 for number 1. Looking at number 2, these 8x and 4x angles are same side interior. They have to add up to 180. So we have 8x plus 4x equals 180, which gives us 12x's is 180, which gives us x is equal to 15. Now if x is equal to 15, this must be y. These two together need to be supplementary to each other because they're going to be same side interior angles. So 8 times 15 is 120, and 60 is going to be this supplementary angle, and we have 5 y's is 60, which means y is going to be 12. Let's look at number 3. Okay, we got parallel lines. So here we have this 140 can jump over here with parallel lines. This is supplementary. It's a linear pair. That means that y is going to be 40. And then by corresponding angles with these lines being parallel, these have to be equal. So we have 2x's plus 10 has to equal the 40. Take away 10 from both sides. 2x's is 30. X is going to be 15. That's how we get those. Okay, looking at number 4, let's see what we got. Well, we can use vertical angles. We know that's going to be a 70. All together, these have to make 180. So the 40 and the 70 makes 110. That leaves 70 degrees left for y. So y is 70. And then what else can we do? Oh, we got 70 there. Parallel lines cut by transversal. If we do the z, this z here means that this angle here has to be 70 by alternate interior. This gives us 110, which means that x also has to be 70, since they need to all add up to 180. So x is also 70. Looking at number 5, let's see. Parallel lines, transversal, 65 and y are corresponding. So y has to be 65. And 55 can jump across by vertical angles. Now all together these make a straight angle. So we have 65 and 55. That's going to be 120. And 120 from 180 leaves 60. So x is going to be 60. Looking at number 6, parallel lines cut by a transversal. Now this is a little bit trickier. Like we can't just directly say that x is going to be 50, even though it looks like it is. Let's see what we got here. Let's see. So we got alternate interior angles. That leaves a 50 down here. So we got 50 there. Now together this makes perpendicular. And then this makes corresponding. So this turns this into a 90-degree angle because these add up to 90. And then by corresponding angles, y is going to be 90. Now we have a adjacent angle, which means that's going to be a 90. We have a 90 and a 40 inside this triangle. That adds up to 130. And 180 take away 130 is going to be the measure of angle x, because 90 and 40 add up to 130. That gives us 50 degrees is the measure of angle x, or the measure of x. So x equals 50.